Okay, good morning, everyone. We're going to do some more practice questions in science. We're just going to continue what we did last time we did this. So we're going to get started here. So if you look, basically, what I meant to tell you guys last time, I think I did, is we want to read kind of the answers first. So these are all about tigers, A, B, C, and D. And it's going to ask about the type of tiger. So let's go up, and if you look at A, tigers with more fur or more colorful and better suited survive. Tigers with more fur were less colorful and better suited survive. Tigers that were harder to see that made more fat were better suited, and tigers that were harder to see and less fat were better suited survive. So this is all about tigers surviving. So let's go up and let's read this little passage. It says there are 6 living subspecies of the tiger on Earth. One of these subspecies is the Siberian tiger. It says the Siberian tiger lives primarily in northern climates where temperatures can get as low as 40 degrees below Celsius. The Siberian tiger has some physical characteristics that differ from other subspecies of the tiger listed below. It says it has lighter color with paler stripes that are brown rather than black, thicker fur around its neck, extra fur on its paws, and layers of fat along its belly. Okay, so which of these best describes how natural selection could have led to these adaptations in the subspecies? Tigers with more fur that were more colorful better suited survive and reproduce in the warm, dry northern climate. Okay, so pretty much we can cross that one out because the paragraph above doesn't talk anything about warm, dry climate. It's cold climate. Okay, so we know it's not going to be A. B says tigers with more fur and that were less colorful better suited to survive and reproduce in the harsh, cold northern climate. Okay, that one kind of makes some sense. So we're going to not cross B off. C, tigers are hard to see and had more fat were better suited to survive and reproduce in warm, dry northern climates. Once again, there's nothing in that paragraph above that talks about warm, dry climates. So we're going to cross that one off. Tigers are hard to see and had less fat, were better suited to survive and reproduce in the harsh, cold northern climate. Okay, that one sounds okay too, but what you have to look at had less fat. And up top, the 4th bullet says layers of fat along its belly. So that one isn't going to work either because they have extra fat. So then we go back to B. Tigers with more fur and that were less colorful, better suited to survive and reproduce in the harsh, cold northern climate. That one's going to be the answer. And if you think about it, excuse me, less color means they're going to blend in with the snow in a northern climate. That way predators can't see them. I'm not sure what, maybe other than polar bears might be their primary predator, but lighter skin suits in with the snow. Having extra fur on their paws keeps their paws warm. Extra fat in their belly keeps them warm, and thicker fur around their neck is going to keep them warm. So that would be perfect for tigers living, up around the North Pole region. So we're going to go B is going to be the correct answer just by process of elimination. Okay, so let's go on to 6. Okay, 6. It says an organism is made up of different cells with specialized structures inside that help carry out its purpose in the organism. Which type of cell would have the greatest number of mitochondria based on the main function of the mitochondria in the cell? Specialized structures help carry out its purpose in the organism. So we have muscle, skin, bone, and fat. Okay. So we're going to kind of see muscles. We're in class. Muscles, that's how we move. We walk, our muscles in our legs move. When we basically go up the stairs, the muscles are the thing getting us up the stairs. So muscle seems like a pretty good one because it helps carry out the purpose. Skin, maybe skin is just kind of a filter. All right. Bone is just kind of keeps everything in place. And fat, we really don't need very much fat. So if we look at 4 of those, we're going to have to ask ourselves, which one carries out the purpose? Which one is most useful in the human body for carrying out its purpose? And you're going to look at that, and they all have their purpose. But the muscle basically is going to give us the most function. And that would be the correct answer. It would be A. And that one doesn't give you a whole lot of information. Okay, so you're going to probably, this one, if you weren't in class and didn't understand about mitochondria, we talked about cells, it might be a little bit difficult, but you're going to look at really what fat does. Fat basically doesn't really, it's kind of unhealthy. So that one you can probably cross off right off the bat and say it's not going to be fat. So then maybe you're left with muscle, skin, and bone. Okay. Skin is maybe important, but you know, really what skin does, it just kind of protects us, and it serves kind of as a barrier from infections kind of getting into our body. So I think really you will get down to muscle and bone, and without muscles, we couldn't really move. Bone is important because it gives us a structure of our body, but it's a muscle that allows us to move. So in that one, you might just have to cross off fat. And then if you're not sure you're going to have muscle, skin, and bone, then you're just going to have to think, which one gives me basically carry out its purpose? And the muscle really would be the best answer. And if you don't know, you've crossed off fat, but at least you have a 33%. You have muscle, skin, and bone. Okay, so what we've done here, you've got a question that you might not know exactly, but by crossing off fat, you've improved your chances to 33%. Okay, then you just have to really think, muscle, skin, or bone, which one's most important? Okay, and it was A. Okay, let's go on to 7. Which investigation would provide evidence about the effect of rainwater on the chemical weathering of different kind of rocks? Okay, so these are basically going to be kind of 3 experiments. Excuse me, 4. Okay, so the first one says place drops of heated water on different kinds of rocks, then use a hand lens to observe any record of reactions that occur. Okay. B, place different samples of rocks in purified water, then measure the amount of time needed to dissolve each kind of rock. Okay. C, place different samples of different kinds of rocks in slightly acidic water for several days, then remove the rocks and evaporate the water to measure the amount of rock material that dissolved. Okay. And place different kind of rocks in a slightly alkaline water for several days, then remove the rocks and evaporate the water to measure the amount of the rock material that dissolved. Okay. So if you go up to the question, which investigation best provides the evidence of rainwater on the chemical weathering? So it's about chemicals on rocks. So heated water doesn't have any chemicals in it. At least it doesn't say that. So we know it's not going to be A. Okay, because there's no chemicals in just that heated water. B talks about placing samples of different kinds of rocks in purified water. So purified water, that's just when you put in a water filter and it's taking the chemicals out. So it's not going to be A or B. So we've got it down to C or D here. Okay, so C says place samples of different kinds of rocks in slightly acidic water for several days. Then remove the rocks, evaporate the water to measure the amount of rock material that dissolved. So that one you're kind of measuring what the chemicals did on the rock to see how much of the rock dissolved. And the last one says place samples of different kinds of rocks in slightly alkaline water. So alkaline and acidic on a scale, basically it's just acidic means it's got a higher pH and alkaline has a lower. Okay, so it's just 2 different types of chemicals. So D says place samples of different kinds of rocks in slightly alkaline water for several days. Then remove the rocks and evaporate the water, measure the amount of rock material that dissolved. Okay, so it's going to be C or D. And they're both asking kind of the same thing. Okay, so, but we know that acidic acid is a real, think of like battery acid in your par. Acid's going to dissolve something. Alkaline is low, it's not really going to do much. So this one, it would have to be, if you got it down to C or D, you got a 50% chance. Then what you'd have to draw on is your knowledge of what difference between acidic and alkaline, okay? And acidic is going to have more an effect than alkaline, okay? And that would just be from basically being in class and kind of knowing the difference between acidic and alkaline. But if you didn't know that, that's fine. What you've done though is you've crossed off A and B and you're down to a 50% chance. And then even if you guessed D, you made an educated choice. And if you got C, then you got the right answer. Hopefully you had some knowledge of the difference between alkaline and acidic. And if you did, then you would know it's C. Okay, let's go on to, there's two more. Okay, and this shows a terrarium with several green leafy plants of the same species and several snails of the same species. The diagram represents the exchange between chemical compounds between snails and plants. Okay, so in class we did a unit on plants, basically trees, they take in carbon dioxide. And when we breathe out, we give it off. And what the plant does, they take in the carbon dioxide and they produce oxygen. So that's really the difference between like kind of a plant and animal here. They're using a snail, but kind of snail would give off carbon dioxide. The plant would take that in and then turn that into oxygen. Okay. So what this says is normal atmospheric carbon dioxide is composed of carbon T symbolized as 12C, carbon 14 or 14C. That's carbon dioxide. And that's when we breathe, that's what we give off. And it says carbon dioxide is a radioactive isotope of carbon that is used to follow the path of carbon compounds as they are transferring and transformed by the reactions that make up a chemical process. A path of compound containing carbon dioxide can be followed by measuring radiation at different points. A biochemist plans to use C14 containing compounds instead of the chemical interactions between a species of a green leafy plant and a species of a snail that feeds the plant. The two species were placed in a terrarium to isolate them from surroundings. Okay. All that's saying is we're going to study what happens when we put a snail and a plant in that terrarium. So it's basically sealed off. So the only two things you're going to have is the plant and the snail. And the snail is giving off carbon dioxide, okay? And you can look at those arrows. So arrow A and B in the diagram represent molecules exchanged in the snail and the plant. The snail combines molecule B with other materials to make larger molecules such as proteins. So it's basically what the snail is giving off, the plant is taking in. And when the plant is giving off, the snail is taking in, okay? So it says, what is molecule B? Okay, so is the plant giving off water? Nope. So we know it's not A. Is it giving off oxygen? It is, okay, but it's also giving off other things as well. But we're going to know it is giving off oxygen, so it's going to be, we're going to keep B in there. Then it looks at glucose. Glucose, if you look at the last, the O6, we know there's oxygen there as well. And their D is carbon dioxide. Snail basically is basically giving off B, but the plant is not. The plant is giving off oxygen. Okay, so that basically leaves us with B or C. Okay, so this one you're going to see, just like us, is a human when we breathe, is that the only thing that basically we give off is oxygen? And the answer is no, there's a little more we give off than just oxygen, just like the snail. And the correct answer would be C. But once again, that one can be a little bit tricky, but you've got it down to B or C. Okay, So we know it's oxygen or glucose. Okay. And that one, once again, if you didn't have any knowledge, you would just basically know it's either going to be answer B or answer C. And if you look up basically here, you know, the C14, which is carbon dioxide, or C12, there's some other things in that as well. That's how you know basically it's giving off a little more than oxygen. And that would be the glucose, okay? So that would probably be C would be the correct answer. But once again, by process of elimination, we've taken out A and D, and it leaves us with a 50% chance, okay? So let's go on to 9. Okay. So when a radioactive material has been introduced into an isolated ecosystem, that's a terrarium, the plants and snails become slightly radioactive over time. Which material do snails release that makes them less radioactive? Okay, that's just like humans. So what do we give off that makes us less radioactive? Do we give off water? No. Do we give off oxygen? No, we breathe in oxygen, just like the snail. Glucose, possibly, but carbon dioxide, D, is really what we give off, and that is the thing that's going to make the snail less radioactive. Just like when we breathe out, we give off carbon dioxide. We need to get that out of our system, okay? So the correct answer for this one would be D. And once again, you guys, you probably got it down to C or D. And then we have to realize that carbon dioxide is something, it's kind of like a poison. We want to try to get rid of it out of our body, just like this snail. But once again, if you basically got it down to C or D, you've given yourself a 50% chance once again. And by picking D, that would be the correct answer, because that's kind of a, you know, poison. And we talked about that in like our photosynthesis lesson. So for some of you, you might want to go back and look at photosynthesis, and that's really what this talks about. And that would talk about the carbon dioxide. So that would be answer D. Okay, so that's it today for science. I will go ahead and post this. So if you want to go back and look at it later, that's great. And I'll be sending out a socialized link here shortly, and we'll start right about 11 o'clock. Thanks, you guys, and have a nice day.